Okay, in this video what we're going to look at is some Venn diagrams and how we use them to create these, use these with set notation to describe these areas. So the first thing is, let's draw a three-circle Venn diagram. Here's one, here's two, and here's three. Apologize, it's not too round, but the same idea. So we call this A, this B, and C. And as noted, that there are 8 compartments. I'm going to label them 1, 2, 3, 4, 5, 6, 7, and 8. Now the 8th compartment is outside all 3 of these things, and usually there's a box that you box the 3 circles in. So the 8th compartment is outside of A, B, and C. So in one way we could actually start right here. How would I write that 8th compartment? Well, it's not A and it's not B, right? So it's not A, it's A and it's not B, okay? So intersect, nor is it C, okay? So it's none of these, okay? It's not A, it's not B. So A complement is outside of here. Intersect B complement is out of here. So A complement is outside of here. B complement is outside of here, and C complement is outside of here. So it's just the outside of this entire space. We could also denote it as A union B union C. So all of A, B, and C would complemented it. So that's section 8. We could label the outside of all 3 of those circles using either one of these, and you may see by De Morgan's law that these are the same thing. Okay, so that's one thing. Let's just take another one. If I wanted to color a space in, like this one here, I'm going to color this space in here. How do we denote this space? Well, that space in green, I'm sure you'll recognize that space in green is A intersect B, A and B. Now, if I didn't want any part of C in this, I would have to go and further qualify this and say, but not C. So you would say, and not C. So let's take another example of one. Let's do this one here, where we have the little piece of B and C, but we don't want A. So this yellow, we want B and C, but we don't want A. So let's see, how do we label that? Well, using our notation, that is B and C, B intersects C, but we don't want A, so we intersect with not A. So B and C and not A. That's what that area is here. So you can get an idea of how we label these. Let's take a few more examples. I'm going to draw 3 more circles. So let's try labeling some of these areas again. Let's say I just want the area here that is in A, but it's not, I don't want B or C. So how would I label that area? So using the same ideas we've used before, that area is, it's A, but it's not B, so we were going to join it, we're going to intersect it with not B, and we're going to intersect it with not C. So it's A, right, but not B. So anything intersected with not B, which is outside of B, intersected with not C, which is outside of C, and that gives you the purple region. Okay, and you could use De Morgan's laws to simplify this to A and intersect B union, and I'll let you verify this, or B or C complement. Okay, so B or C complement is everything outside of B and C, and we intersect that. We see what it has in common with A. So those are the same thing. Let's do one more here. Let's say I wanted to know this green area here. So this area here, but I'm going to have this area too with it. So what are we doing in that green area? How do I write that using this set or these logic notation that we've been using? Okay, so this entire area here in green, how do we call it? So we know we have B and A, so we say B intersect A, and we also know that we can join it with B and C. Sorry, so I said B and A, but I wrote B and C. So B and C is this piece down here, and then we join it with B and A. B and A. Okay, so B and C is down here, B and C, and this one is B and A, right? So the whole thing, all of this green, is denoted by this notation. So if we use a little bit of some simplification, we could sort of factor out that B and say that's B intersect, or B and what? B and C or A. Now C or A is this entire thing here. These two circles, this one here, this A circle, this C circle, and what do they have in common with B? This little region here, this green region. So again, those two are equivalent. Okay, so I hope this gives you a little insight into how you label these diagrams. And you may want to look over this again and just study that how these operations can be used to label the diagrams. And also, we can use these for circuits, and you can use these Venn diagrams to actually simplify circuits too.